Okay, today we do some questions for the array. Okay, so first program is the like uh, write a program to find the array of like uh, all element of an array. Okay, so for the calculating, make a method. Okay, we make a function with parameter x the array. So take a variable like initialize a variable with 0. And make a loop to the sum of the all elements. Okay, calculate the sum of an array. Then make sure our logic is correct and return them. Okay, find the average and return them. Okay, we create a method find average which return the double types and its parameter is integer typed array. Okay, so first we initialize with the zero some variable, and step by step we count the sum all of the array element, and then we find the average of the array to divided by the length of array and sum of the elements. Then we store the average in the result variable and return the result. Okay, so now in the main method we first initialize the array. Okay, now call method to calculate the average. Okay, we get the average in the average variable and now print the value. Okay, I think our method is ready to run. Okay, now our program is executed. Okay, in this program, the find average method loop through the array and adds up all the elements to the sum. Okay, the find average method loops through the array and adds up all the elements to sum. The sum then the sum is divided by the length of the array. Okay, the sum divided by the length of the array to calculate the average. Then the result is returned as a double to accommodated decimal values. Okay, so the output is the average of array element is 13. Okay, we get this output. Okay, so let's now make then another example. Okay, now we our next program is sorting, like uh, like create a state. Array is sorted. Okay, like an array is sorted if each element is smaller than or equal to the next element. Okay, like for ascending order, we will write a method that checks a condition for all consecutive elements in the array. Okay, so first we create the method. So like make the method. Okay, like if any element is greater than the next one, it's not sorted. So then it's return false. Okay, it's check the condition step by step one, then it makes sure it's ascending order. But the if any element is find greater than the next one, it means it's not sorted and return false. Okay, if loop finishes without returning the false, the array is sorted. Okay, okay, initialize an array. Okay, so now we print whatever were the, okay, is sorted is equal to true, then print the message like the array is sorted. Okay, and if the condition is false, else. Okay, then first check or condition first we initialize the array. Okay, so array is sorted. Then we check the, okay, call the functions and and else. Okay, so the output is look like this. The array is sorted. Okay, because our array is already in ascending order. Okay, then execute it. Okay, we get an error. Exception. Okay, throw an exception. Exception threads in main.java line. Index 5 out of bounds for length 5 8. Okay. Okay. So the message is print like this. The array is sorted because our array is already sorted. But 14 and 13. Now the array is not sorted. Okay. Now it's not in the correct ascending order. Okay. So now the message is print like this. The array is not sorted. Okay. So the sorry, okay, the is array sorted method compress each element with the next one in the array. Okay, if any element is greater than the next one, the method return false. If the loop completes without finding such a case, the method returns true, indicates the array is sorted. Okay. Okay. If we change the array, then the output is look like this. The array is not sorted. Okay. So now we try the last program for the array. Okay. Like to implement a program to merge two sorted array into one sorted array. Like to merge two sorted array, we can use two pointer approach. We compare the elements of both array one by one and add the smaller element to the result array. Okay, this way we maintain the sorted order of the merged array. Like first, I'll remove the unnecessary code. Okay, so first make the method. Okay, make parameters which is integer data types. Return the integer data types, and it's have two parameters, array one and array two. Okay, so find the length of array like in n1 equal to array1 dot length and int into equal to. Okay, now here we find the length, both two arrays, and create a new array to store the merged result. Okay, so like make some variables. Merge the array while both arrays still have like elements. Okay, so we make the implement the logic here. Okay, first we make a loop where has two parameters, array 1 and array 2, and here we initialize the two variables with the length of array 1 and array 2, and now here we create an array which is store the merge result. Okay, means new array. Okay, and here we take three variables which is initialized with the 0 I, j and k. So here merge the element while both arrays still have elements, means okay, add elements from a here and add elements from the array 2. Okay, if array 1 is greater than array 2, array 1 is less than from the array 2. Okay, then merge from the array 1, and otherwise add from array 2. Okay, and while this also, okay, then cross check, and here return the merged value. Okay, now work on our main method. Initialized to array. Okay, now call the method here. and print the value of new array. Convert the array to string. Okay, now execute the program. Okay, so here's the result. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, when I change the numbers like this, then I will execute it. Then the result is look like this: 1, 2, 10. Okay. Okay, merge only two sorted array. Okay, not it one unsorted array. Okay, we initialize two stored array 1 and array 2. Array 1 and 2. We use the three pointers here I, j, k to traverse through the array and the result array. The elements are compressed at each step. The smaller element is added to the merged array, and after the one of the array is fully traversed, the remaining element of the other array are copied to the merge array. Okay. Okay. Today we covered the three some questions about the array, like finding the array. The program calculate the average by summing all elements and dividing by the number of elements. And the second is the checking if array is sorted. It checks if each element is smaller than or equal to the next one. And now we merge two sorted arrays. It used two pointer techniques to merge two already stored array into a single sorted array. Okay, so we covered the topic of array. Now, in the next session, we will learn about the linked list. Linked list. Okay. So, in the next session, we will learn about the linked list, like what is the linked list, what's the okay. So, first, I will give you a brief introduction to the linked list. Okay. So, a linked list is a fundamental data structure in computer science. It mainly allows efficient insertion and deletion operation compressed to array. Like array, it is also used to implement other data structure like stack, queue, and dequeue. Okay, here's the comparison of linked list versus array. Okay, data structure like the linked list is the non-continuous data structure, but the array is the continuous data structure, and the linked list typically allocated one by one to individual elements, and in the array, the memory allocation typically allocated to the whole array. Okay, in the linked list is allocated one by one, and but in the array, the memory allocation is the whole array, and insertion and deletion operations perform with efficiently in the linked list, but the in it inefficient. Okay, and the axis is the sequential, not randomly, but in the array, the axis is randomly. Okay, so a linked list is a linear data structure where elements are sorted in nodes. Each nodes contain two parts, the data part and the reference, or link to the next node in the sequence. Unlike array, where elements are sorted in continuous memory location, linked list linked list sorted elements at non-continuous locations. This structure allows dynamic memory allocation, meaning it can grow and shrink as needed, unlike arrays that have fixed sizes. Okay, so I will give a example. Right. Okay, there is an example for the linked list. Okay, so let's discuss about the benefits of linked list. Is that dynamic size. Unlike array, linked list can grow and shrink in size as elements are added or removed, making them more memory efficient creation cases. Like unlike array, linked list can grow and shrink in size as elements are added and removed, making them more memory efficient in certain cases, like efficient insertion or deletion. Inserting and deleting elements is quicker, like If you have direct access to the node, is there no need to shift other elements, unlike in array. Okay, and it's provide flexible memory uses like linked list don't need to reverse reverse large block of memory at once. Memory is allocated as needed. Okay, like the advantage of linked list. Okay, there are many data structures like array linked. Each short agreement has a like a linked list is a dynamic arrangement that contains a link to the structure, contains the subsequent items at a set of structures ordered not by their physical placement in memory, like an array, but by logical links that are stored as part of the info within the structure itself. A linked list is another way to collect similar data. However, unlike an array, elements during a linked list are not consecutive memory locations. Okay, a linked list consists of nodes that are connected with one another using pointers. The figure it's a linked list. Okay, the each nodes are connected with the each other like A, B, C, and D. Okay, each node are connected to the each other. Like there are some types of linked list like single linked list. It is a simple type of linked list in which every node contains some data and pointer to the text node of the same data type. Okay, a single linked list allows the traversal traversal of data only in one way. Okay, and there is double or two-way linked list. A double linked list or a two-way linked list is a more complex type of linked list that contains a pointer to the next as well as the previous node in sequence. Therefore, it contains their parts of data, a pointer to the next node, and the pointer to the previous node. This would enable us to traverse the list in the backward direction as well. Next is the curricular linked list. Linked list. Header linked list. A header linked list is a linked with the additional header node which store the extra information about the linked list. Okay, so there are some advantage of linked list. Dynamic data structure. A linked list is a dynamic arrangement, so it can grow and shrink at runtime by allocating and deallocating memory. Okay, it can grow and shrink at runtime by allocating and deallocating memory. Like insert, it's grow and shrink when inserting data by allocating and deallocating cation memory. Okay, so there is no need to give the initial size of the linked list like array. Okay, so no need to give the initial size of the linked list. And next is the no memory wastage. In the linked list, efficient memory utilization can be achieved since of the size of the linked list increase or decrease at runtime. So there is no memory wastage and there is no need to allocate the memory. And next is the implementation. Linear data structure like stack and queue are often easily implementation using a linked list. And next is the insertion and deletion operations. Insertion and deletion operations are quite easier in the linked list. There is no need to shift elements after the insertion or deletion of the element. Only the address present in the next pointer need to be updated. And next is the like flexible. This is because the elements in linked list are not stored in continuous memory location, unlike the array. And the next is the efficient or for large data. When working with large data sets, linked list play a critical role as it can grow and shrink dynamically. Okay, when we work with the large data, then it's better for insertion and deletion operations because it can grow and shrink dynamically. Okay. Next is the like scalability, contains the ability to add or remove elements at my position. Okay. Okay, like some disadvantage of linked list is like memory overhead. Each node require extra memory for sorting the pointer reference to the next node, which makes linked list more memory intensive than array. And like next is exist time. Unlike array where elements can be accessed directly using an index, like the list requires traversal for the head node, which make accessing elements slower. Okay. Like it contains more time complexity. Okay. Implementing linked list require extra code and careful handling of pointer. Like there is some disadvantage of the linked list. Like memory usage, more memory is required in the linked list as compared to an array because in a linked list a pointer is also required to store the address of the next element and it requires extra memory for itself. Okay, so next is the traversal. In a linked list, traversal is more time consuming as compressed to an array. Direct access to an element is not possible in a linked list as in an array by index. For example, like for accessing a node at position, one has to traverse all the nodes before it and reverse traversion. In a single linked list, reverse traversion is not possible, but in the case of a double linked list, it can be possible as it contains a pointer to the previously connected node with each node. For performing this, extra memory is required for the back pointer here. Hence, there is a wastage of memory. Like random access is not possible in the linked list due to its dynamic memory allocation. And next is the lower efficiency at times. For creation operations such as searching for an element or iterating through the list can be slower in a linked list. And next is the complex implementation. The linked list is implementation is more complex when compared to array. It requires a complex programming understanding. Okay. The linked list requires a complex programming understanding because the linked list is implementation is more complex when compared to array. Difficult to share data. The because it is not possible to directly access the memory address of an element in a linked list. Okay, and not suited for small data sets. Cannot provide any significant benefits on small data sets compared to compare to that of an array. Okay, so some use cases of linked list is like dynamic data structure. Linked lists are ideal when the number of elements is not working, not known beforehand or changing frequently. And like implementation of other data structures, like many other data structure such as tray, queue, graphs, etc., are often implementing using linked list. Okay. So the next is the why is linked list useful? Because memory efficient. Since linked lists are dynamic, they use memory efficiently, especially when the size is unpredictable. And it's faster insertion and deletion. Linked list allows quick insertion and deletion, especially in scenarios where elements need to be added or removed frequently without needing to reorganize and reorganize the entire structure. Okay, so we will learn about some examples in the next session. Okay, so Neha, let's end the today's session and we will discuss about the linked list and queue and DQ in our next session. Okay, hello Neha. Hello Neha.
Okay, thank you. Bye bye.
Yeah, yeah, okay, bye bye.